We can also represent the p-n junction with this band diagram. The y-axis here is the energy, and you can see the valence band and the conduction band for the p-type material and the n-type material. The p-type material is on the left, and it is distinguished, we know it's the p-type, because we have these lower energy holes here below the level of the conduction band. So that means that the other one is the n-type, and that makes sense because it has these higher energy electrons above the valence band. No current flows in this p-n junction because the holes are higher in energy than the electrons. The electrons would have to go up in energy to match with the holes, and they don't do that. So that leads to a depletion region at the junction, just like we saw before. We can depict how forward biasing would change the energy levels of the p-n junction. Forward bias would supply some higher energy electrons that now do have sufficient energy to diffuse over to the p side, and so now current can flow. Basically, the way that this looks is that the sort of band bending at the edge here gets a little bit shallower. In the case of reverse bias, where we've attached the negative terminal to the p side and the positive terminal to the n side, that makes the holes go higher in energy and the electrons go even lower in energy. So now we get an even bigger depletion region because the electrons would really have to go up high in order to meet those holes, and so no current flows.